Welcome back to RamZland. Today I want to show you the amazing redox reaction between iron sulfate and potassium permanganate. Check this out.
For this experiment, we'll be using iron sulfate, potassium permanganate, 200 milliliters of distilled water, a petri dish, a dropper, and 98% sulfuric acid, H2SO4. Begin by measuring out 100 milligrams of potassium permanganate. Then add the potassium permanganate to 200 milliliters of distilled water. Once the potassium permanganate is completely dissolved in the solution, add a drop of concentrated sulfuric acid to acidify the solution of potassium permanganate. Now measure out 1 gram of iron sulfate. In a second beaker of 200 milliliters of distilled water, add your 1 gram of iron sulfate. Stir until the solution is completely aqueous. Just for future contrast, I'm going to add a little bit of our acidified solution of potassium permanganate to a petri dish.
And now we're ready to test this rather exciting redox reaction. I'm just going to add a drop of my acidified potassium permanganate to my solution of iron sulfate. Check out what happens. Well, that's strange. It seems as though the color vanishes. Let's take a closer look.
Here again are both beakers side by side. I'm adding my solution of potassium permanganate, and you can see that dark purple color just vanishes. How is that possible? I wonder what would happen if we added the solution of iron sulfate to the solution of potassium permanganate. Let's try that in a petri dish. Okay, here's our petri dish of acidified potassium permanganate, and let's see what happens when we add our iron sulfate. It looks like it's starting to change the color of it, almost as though it's making it clear. Look at that. It's actually starting to turn clear. Isn't that amazing? Just look at that. Such an amazing reaction. Looks like all those manganate ions have been reduced as they're gaining electrons. And it looks like our iron ion is being oxidized as it loses electrons. Look at that. Here's the balanced equation for this amazing redox reaction. We start with the reactants, potassium permanganate, iron 2 sulfate, and sulfuric acid. We have 2 moles of potassium permanganate, that's the 2 KMnO4, 10 moles of iron 2 sulfate, that's the 10 FeSO4, and 8 moles of sulfuric acid, that's the 8 H2SO4. When those are combined in an aqueous solution, we get the products potassium sulfate, manganese sulfate, iron 3 sulfate, and water. We have 1 mole of potassium sulfate, that's the K2SO4, 2 moles of manganese sulfate, that's the 2MnSO4, that's the clear solution, and then we have 5 moles of iron 3 sulfate, that's the 5 Fe2SO4 and 8 moles of water, that's the 8 H2O, in this amazing reduction oxidation reaction. So in this reaction, the manganate ion and potassium permanganate is being reduced. That means it's gaining electrons. Its oxidation state changes from a +7 to a +2 as it gains electrons. Whereas the iron ion is being oxidized, it's losing electrons as it changes from an oxidation state of +2 to +3.
I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.